Let's go ahead and see question number 3. For question number 3, we have 2.4 grams of sodium hydrogen carbonate is added to excess acetic acid at 1.003 atmospheric pressure and 299 Kelvin. When the reaction is stopped, carbon dioxide gas was collected over water in a tube and measured volume was 0.6 liters. The vapor pressure of water at 299 Kelvin is 24 millimeter mercury. So this is in millimeter mercury and this is in atm. So I have to convert that first. I will just keep it like that. 24 millimeter mercury divided by 760 will give me that answer, which equals, how much is that, is 0.03158 atm. So pressure conversion is done, and then I will write the equation. So acetic acid, we wrote this one several times, right? Vinegar plus baking soda will give us, either you can write like this, NaCH3COO plus CO2 plus water, or you can write the same compound CH3COONA. Both are okay. And now I have 2.4 grams of sodium hydrogen carbonate, 2.4 grams, and other information given for carbon dioxide. So that means 1.003 atm, and that is the pressure, and it is over water. So I have to calculate only for carbon dioxide. So 1.003 atm minus how much I got here is vapor pressure 3158, both are in atm. So what is that going to be is, when you subtract, you will get 0.97142 atm. I got the pressure, and what's the temperature given is 299 Kelvin. What's the volume given is 0.6 liter. What else? That's it, right? So first we had calculated the number of moles of carbon dioxide produced. So I have pressure, volume, and temperature. So that means I know the R, gas constant, 0.0821 liter atmosphere. So it is liter atmosphere. So it is Kelvin. Okay, so the units are matching. So PV equal nRT. So N equal PV over RT. So pressure is 0.97142 and volume is 0.6 divided by 0.0821 times 299. How much is that going to be is number of moles I'm getting as, when you plug it in the calculator, I'm getting that one as 0.0237 moles. So we have done the number of moles here, and now they're asking number of moles that would be produced if 2.4 grams of sodium hydrogen carbonate was converted and collected in the tube. So that means the whole 2.4 gram. So this is going to be my actual yield, because that is through experiment I got this one. And now if I'm just calculating using the stoichiometry here, just using the balanced chemical equation, that will be my theoretical. That is what they are asking in here. Okay, so theoretical 2.4 and the molar mass of baking soda is 84. So that equal how many moles is that? Is 0.02857 moles. So that means if I have 0.02857 moles of NaHCO3 and 1 mole of NaHCO3, I have 1 mole of carbon dioxide, 1:1 ratio. So we can easily say that the number of moles of carbon dioxide is 0.2857, right? And then we have to convert that one into mass. So that means carbon dioxide molar mass is 44, that equal 1.257 grams. So we are done with that part as well. So this is our theoretical yield. So then calculate the percentage yield is actual, that is, okay, this is moles, I have to convert it into grams. Okay, otherwise I have to just use the moles and moles here, or we have to convert this one into grams and use the grams. So moles to mole or grams to grams. Okay, so that means 0.237 times 44 will be it is equal to, so 1.0447, that is times 44, that will be in grams. That is our actual yield. So that means percentage yield will be, okay, percentage yield equal actual 1.0447 divided by theoretical is 1.257 times 100, right? That means I'm getting that one as 83.11 percentage. That's going to be your percentage yield. So that's how we are doing that question. And one more question, let's go ahead and try, which is what mass of precipitate can be produced when 50 milliliters of 0.2 molar aluminum nitrate is added. So first I have to write the balanced equation. Aluminum nitrate added to KOH. So I'm getting the product aluminum hydroxide, which is the solid. This is going to be soluble, so AQ, because potassium is in the first group, nitrate, all nitrates are soluble. And then I'm going to get KNO3, and then I have, this is also soluble, NO3 and K, so we know that. And then we have to balance it, 3KNO3, and I had to have 3 potassium here, 3 hydroxide, so 3 hydroxide. And then the information, 50 milliliters and 0.2 molar. So I can calculate the number of moles. I will convert it into liters. Otherwise, I will get millimoles, which I don't want now. So that equals 0.01 moles. And I will do the same for KOH. For the KOH, they have given 200 milliliter. And I have 0.1 molar, right? So I will have number of moles as 0.02 moles. So we know this is the limiting reagent. We don't have 3 times of this one. This is 0.1 and the mole ratio is 1 to 3. So I don't have 3 times of that. I'm supposed to have 0.03, but I don't have it. So this is limiting reagent, correct? And then I know, so this is going to decide how much aluminum hydroxide is forming. So I will see how many moles of aluminum hydroxide will be forming by taking 0.02 moles of KOH times the conversion factor is going to be 3 moles of KOH, and that is corresponds to 1 mole of aluminum hydroxide. KOH and KOH, and I will just divide by 3, that means I will get 0.00667 moles, right? Moles of aluminum hydroxide. And then what am I supposed to do? This is my theoretical yield. And did they give, okay, so they are giving us 85.3% yield of precipitate formed. That is their percentage yield. They have given us as 85.3%. So what I will do is I will convert these moles into grams. So aluminum hydroxide, the mass is going to be 20. I'm just taking the rounded 27 plus 15.99 times 3. And hydrogen, there are 3, so 3 times 1.008. So that when you do that, you will get that one as, and then multiply that one with our number of moles, 0.00667, right? So that will give me the grams, which equals 0.52. So that means I'm getting my actual over theoretical times 100. So that means I don't know the actual. The theoretical is going to be 0.52 and then times 100. So when you rewrite, we have to find 85. Let me just take so that 85.3 times 0.52, right? And then divided by 100. That equal, the mass is going to be 0.444 grams. Do the math and try, and you may have to calculate this one to get in the grams, and then I'm substituting in this percentage yield formula because they have given the percentage yield. I'm finding the actual yield. Okay, so the answer is supposed to be 0.444 grams, just little different type. I hope you have an understanding. So if you have any question, let me know. Thank you.